Today, we're diving into a piece of tech that's so simple you could almost overlook it, but it does something absolutely vital for human safety. We're going to pull back the curtain on the pocket dosimeter, this amazing little device that lets us see a fundamental force of nature that is totally invisible.
I mean, think about that for a second. It's a real puzzle, right? If there's a danger you can't detect with any of your senses, how do you even know it's there? And more importantly, how do you protect yourself from it? Well, that's the exact problem we're going to solve right here. So first things first, let's get to know what we're up against. And this isn't something you can just sidestep or outrun. Nope, we're talking about a fundamental force of the universe.
Yeah, that's right. It's this powerful energy that can pass right through your body, and you would have absolutely no idea it's happening. It's not like heat that you can feel on your skin or light you can see with your eyes. It's a totally silent, invisible threat, which is exactly why having a special tool to detect it is an absolute must for anyone working nearby.
So how in the world do you fight an invisible enemy? You do it with an incredibly elegant and, frankly, brilliant solution. So let's meet the star of our show, the pocket dosimeter. And that's the real genius of it. It's not some huge, complicated piece of lab equipment. It's this personal, portable little gadget you can literally clip to your pocket. And its biggest advantage? It's not sending data off to some lab to be analyzed later. It gives you the answer right here, right now.
But how does this little pen actually work its magic? Well, you know what? It's not magic at all. It's just brilliant, old-school physics. Okay, let's dive in and see how it works.
So if we were to crack this thing open, we'd see it's a beautifully simple machine. You've basically got an ionization chamber, this super delicate quartz fiber, a tiny microscope, and a scale so you can read the results. Now let's see how these parts all work together.
Okay, the heart of the whole device is the ionization chamber. You can think of it as the arena where all the action happens. It's just a small, sealed tube filled with air. When radiation passes through it, it literally knocks electrons off the air molecules, which creates these little charged particles called ions.
The whole thing works on a really basic principle: static electricity. First, you charge the device up. That charge forces a tiny, metal-coated fiber to bend away from a post it's attached to, kind of like how static electricity can make your hair stand on end. Then, as radiation comes into the chamber, it makes the air inside conductive. This allows that static charge to slowly leak away. And as the charge disappears, that little fiber starts to move back to where it started.
So here's the key takeaway. The more radiation that passes through, the more conductive the air gets. The faster the charge leaks away, the more that fiber moves. It's a direct one-to-one mechanical measurement. Simple as that.
And that quartz fiber, it is incredibly fine and delicate. The best way to think of it is like the needle on the speedometer in your car. Its movement across a tiny little scale inside is what tells you everything you need to know. Okay, so we've got the science down. But what's it actually like to use one of these things? Well, the beauty of this device is that reading it is just as simple as its design. Seriously, all you do is hold it up to a light source like you're looking through a tiny telescope. When you look inside, you'll see a numbered scale, and right on top of it, you'll see the shadow of that quartz fiber. Wherever that shadow is pointing, that's your radiation dose. It is that simple and that immediate. Now, the numbers you see on that scale, they're measured in units called millirongens. Just to give you a little bit of perspective, the average person gets exposed to around 300 to 400 millirongens every year just from natural background radiation from space and the Earth. A super common version of this device has a scale that goes all the way up to 200 millirongens. This gives the user a really clear visual idea of their cumulative dose. You start the day at 0, and you can instantly see how much you've picked up during your shift. It's an incredibly useful tool.
So, now that we know how it works and how to read it, let's talk about where it really makes a difference. I mean, who are the people clipping this little pen to their lab coat or their work vest every single day?
Well, it's an absolutely essential tool for a whole range of professionals. We're talking about technicians at nuclear power plants, radiologists in hospitals, scientists working in research labs, and, so important, first responders who might be walking into a completely unknown situation. For these people, this isn't just a tool, it's a lifeline.
And that really is the bottom line. This dosimeter empowers people. It gives them immediate knowledge right in the palm of their hand. It lets them make critical decisions about their own safety on the spot, whether it's okay to stay in an area, if they need to limit their time, or if they need to get out immediately. It puts safety directly into their hands. When you boil it all down, that's what this is. It's an elegant, simple, and tough little tool that does something truly remarkable. It takes this powerful invisible force and translates it into a simple line on a scale that absolutely anyone can understand.
And that kind of leads us with one last thought. This simple pen was designed decades ago to make radiation visible. And it makes you wonder, doesn't it? What other invisible forces are all around us every day that we just can't perceive yet? And what clever new tools are we going to invent to finally see them?